కోచింగ్ అంటే ఇవి అంటే ప్రైవేట్ కాలేజెస్ లో మేము వింటుంటాం సార్. ఇక్కడ మేము సిటీలో ఏదైనా ప్రాక్టికల్ ఎగ్జామ్ అట్లా వెళ్తుంటే ఇట్లా కేడీస్ అని ఏదైనా సందర్భం వచ్చినప్పుడు వాళ్ళు స్పెసిఫిక్ అంటారు ఆన్లైన్ కోచింగ్ ఇస్తున్న అదేనా కాలేజ్ అని. అట్లా ప్రైవేట్ కాలేజెస్ నుంచి కూడా రెస్పాన్స్ వస్తుంది సార్, తెలుస్తుంది ఇప్పుడు.
అంటే కన్సిస్టెంట్ గా అది అట్లా మెయింటైన్ చేయడం అదే అనమాట.
అవును సార్, గ్రేట్ సార్.
మా టీం అంతా కూడా కేడీస్ లో ఉన్నది.
సార్
సత్యం సార్ కావచ్చు, అశోక్ సార్ కావచ్చు, ఇంకా మురళి సార్, సుంతమా, అందరు కూడా జగదీష్ సార్, టోటల్ టీం కూడా చాలా బాగుంటారు మేడం మా దగ్గర. అంటే లైక్ ఏ ఫ్యామిలీ అనమాట. అందుకే మేము ఎప్పుడు కూడా డిఫరెంట్ అనుకోము, ఒకరొకరు చాలా బాగా ఉంటాం. దాంట్లో మా సత్యం సార్ క్వశ్చన్ అనమాట, ఏది మనకి కార్టిలేజ్ అనమాట మా డిపార్ట్మెంట్ లో. అందరికి మేము ఎప్పుడన్నా గట్టిగా మాట్లాడుకున్నా కూడా సార్ ఏంటంటే అందరి కోఆర్డినేషన్ అంటే ఏమంటాం లైక్ చెప్పిన కదా కార్టిలేజ్ లాంటి.
గ్రేట్ సార్. అనుకున్నాం కానీ ఇంత అది ఎఫర్ట్స్ పెట్టలేము సార్, ఎందుకంటే ఆఫ్టర్ ద కాలేజ్ అవర్స్ ఇంత ఎఫర్ట్స్ పెట్టడం అంటే అంత ఈజీ కాదు సార్. నిజంగా మీ టీం అందరికి కంగ్రాచులేషన్స్ సార్.
థ్యాంక్ యూ మేడం ఫర్ యూ ఆల్సో. మనకి కూడా ఒక అది ఏంటంటే ఒక ఛాన్స్ కేడీసీ తీసుకోవడం, అది ఇంకా కంటిన్యూ చేద్దామని కలీగ్స్ కూడా చెప్పగానే అందరు కూడా ఎవరు కూడా వద్దన్నారు మేడం చేద్దాం. ఫస్ట్ ఏంటంటే మేము అనుకుంది ఏంటంటే ఎప్పుడు ఎవరు స్కిప్ చేసినా కూడా మేము ఎవరో ఒకరం రెడీ ఉండాలన్నమాట. అట్లా రెడీ ఉంటాం. ఇంకా ఇంకోటి ఆఫ్లైన్ అంటేనేమో క్లాస్ లో రీసెర్చ్ పర్సన్ వదిలేసి వెళ్ళొచ్చు. ఇప్పుడు ఏంటంటే కాపులా కాస్తూ ఉండాలి, ఎప్పుడు బ్రేక్ వస్తుందా మళ్ళీ అదొకటి కొంచెం ఉంటుంది. బట్
స్ట్రగుల్స్ అన్ని మీరు చూస్తుంటారు, మీకు తెలుసు కదా. సో మీకు గ్రేట్ ఆపర్చునిటీ, కెమిస్ట్రీ ఫీల్డ్ లో చాలా జాబ్ ఆపర్చునిటీస్ ఉంటాయి. మేమందరము జాబ్ ఫ్యూచర్ ఆపర్చునిటీస్ ఏమేమి ఉంటాయి కావాలంటే మీరు సిపి గెట్ ర్యాంక్ తర్వాత ఒక క్లాస్ తీసుకోమన్నా తీసుకుంటాం. చాలా జాబ్ ఆపర్చునిటీస్ ఉంటాయి అమ్మా, మీకు ఐడియా ఉండదు. చాలా జాబ్ ఆపర్చునిటీస్ ఉంటాయి. ఫస్ట్ మీ గోల్ ఏంటి అంటే సిపి గెట్ బిలో 100 ర్యాంక్ ఆర్ బిలో 50 ర్యాంక్ సియు సెట్ లో తీసుకోండి. తర్వాత మేము ఎలాంటి జాబ్ ఆపర్చునిటీస్ ఉంటాయి సార్ కానీ ఎవరైనా సరే గైడ్ చేయగలుగుతాం. ఆల్ ద బెస్ట్ మరి. ఓకే సార్, థ్యాంక్ యూ సార్.
థ్యాంక్ యూ మేడం, థ్యాంక్ యూ. స్క్రీన్ షేర్ మీ స్టాప్ చేస్తే సార్.
ఓకే సార్.
హలో స్టూడెంట్స్, ఇంకా సార్ గురించి చెప్పక్కర్లే కదా. డాక్టర్ కందాల సత్యనారాయణ సార్, పార్ట్ ఆఫ్ అవర్ ఆర్గనైజింగ్ టీమ్ మా కేడీసీలో ఉన్నాం. ఇప్పుడు సార్ ఆల్రెడీ ఫస్ట్ డే మీ ఇనాగ్రల్ చూస్తారు కదా. సార్ విల్ టేక్ డి బ్లాక్ తో స్టార్ట్ చేస్తారు. ఇంకా ఇన్ఆర్గానిక్ లో చాలా టాపిక్స్ సార్ కవర్ చేస్తారు. ఆల్మోస్ట్ మోర్ దెన్ 25 years సార్ టీచింగ్. ఆల్మోస్ట్ మేమంతా కంటెంపరీస్ అన్ని లెవెల్స్ లో, సెట్, జేఈ మెయిన్స్ లెవెల్లో ఇన్నర్ సార్ బోర్డు కాబట్టి ఇంకా యూ కెన్ ఎంజాయ్ ఇది లైవ్ సెషన్. సార్ థ్యాంక్ యూ సార్.
థ్యాంక్ యూ సో మచ్ సార్.
స్టార్ట్ చేస్తారా? మిమ్మల్ని హోస్ట్ చేసి లీవ్ చేయాలమని.
ఓకే సార్, షూర్ సార్.
మిమ్మల్ని హోస్ట్ చేసి నేను లీవ్ అవుతాం మరి. థ్యాంక్ యూ.
ఓకే సార్, థ్యాంక్ యూ.
రైట్ సార్, క్యారీ ఆన్. తర్వాత ఎండ్ చేసాను మీరు ఇంకా.
ఓకే సార్, నేను చేసేస్తాను.
రైట్ సార్, హోస్ట్ చేసిన మరి లీవ్ అవుతాం.
ఓకే సార్,
థ్యాంక్ యూ సార్. క్యారీ ఆన్. లైవ్ కూడా స్టార్ట్ చేస్తాను.
థ్యాంక్ యూ సార్ మచ్. అదే అక్కడ ఏముంది అది పోస్ట్ చేయండి.
క్లాస్ మీటింగ్ అక్కడ ఉంది కామని.
అమ్మా గుడ్ ఈవినింగ్.
వెరీ గుడ్ ఈవినింగ్ సార్.
గుడ్ ఈవినింగ్ సార్. వెరీ గుడ్ ఈవినింగ్ సార్.
Today I am going to start just a minute amma. Just I want to make someone else to as a host because some disturbances arises, they have to rectify. Just a minute please. Right. So, dear students, is the board is visible to you? Is this okay? Is it clear?
Okay, sir.
Okay. Okay, sir.
So today we are discussing about the D block elements. Okay. In periodic table, you know. So what are there in the periodic table?
Periodic table.
What exists in the periodic table? What do you see in the periodic table?
Elements.
Very good. Elements. How many elements are there in the periodic table?
118, sir.
118, or it may be close to 120, right?
20.
118. Right. Now, so these elements are classified into how many blocks?
4 blocks.
S black,
What are those?
P3D.
SPTS.
What is the basis for the classification of elements into 4 blocks? What is the basis? On which basis the elements are classified into 4 blocks?
Electronic configuration, sir.
Configuration.
Atomic numbers, sir.
Electronic configuration, outermost electronic configuration.
Very good. Very good. Yes. So electronic configuration. Therefore, electronic configuration is a fundamental property of an element. Is it okay? So to describe a specific element to belongs to which group, one should write the electronic configuration. If you are able to write the electronic configuration, means you are able to describe its group. So now tell me, what is the which block? This one?
S black, sir.
S black mode.
Its configuration is?
Next one.
What about carbon? Carbon belongs to which block?
S black.
What is its electronic configuration?
1s2, 2s. 2p2.
So where the last electron enters? In which orbital it is enters?
P.
Therefore, carbon belongs to which block?
P block.
P block.
P black element.
What about calcium 20? It's argon. After argon,
18.
1s2, 18 is over. 1s2, 2s2, 2p6, 3s2, 3p6 is over. What next?
4s.
So the last electron enters to which orbital?
S orbital.
S black.
Calcium belongs to which block?
S black.
S black element.
Now we are entering to scandium. What is atomic number scandium?
21.
What is its configuration?
Argon 3D1 4s2.
Argon. After argon, I will write 4s2. Is it?
Yes, sir.
Then the 21st electron or the last electron in the scandium enters 3D. The last electron enters 3D.
3-1.
So therefore, the last electron enters 3D. Therefore, scandium belongs to which block?
D block.
D block. So now,
D block element.
now please define S block elements. Define S black
Hydrogen,
element.
helium.
Yes, hydrogen, lithium,
Hydrogen,
sodium,
lithium.
rubidium, cesium, francium, beryllium, magnesium, calcium, strontium, barium. All these are S block elements. Please define why they are placed in S block. Because those elements
We have entering the S
The
block.
outermost electron centers into the S block. S block element.
electron differentiating electron. So therefore, elements are classified into 4 blocks based on the electronic configuration. Specifically, the differentiating electron enters into which orbital? So in S block elements, differentiating electron enters into S orbital,
P orbital, D orbital, F orbital.
D orbital. Very good, very good. Here, one more point I want to add. So in the D block elements, you see the scandium, the differentiating electron enters into which orbital?
D orbital.
D orbital.
Ultimately D orbital.
Yes, but not it is in ultimate D orbital, ultimate shell. It is in penultimate shell. So it is not in N, it is N minus 1,
N minus 1.
D level. So therefore, This is the definition of the D block elements. So what are D block elements? D block elements are elements in which the differentiating electron enters into
Penultimate.
N-1 D subshell, or that is penultimate level D subshell. Is it clear?
Yes, sir.
Right. So what is the position of D block elements in the periodic table? Tell me.
Between S and P blocks, sir.
Between S and P.
A blacks between
Yes, the D block elements are placed between the S block and
black and
P block.
A black.
Okay, so that's all. And these are also called
Transition element.
Transition elements.
Elements.
Why they
Except
call it
12th group.
transition elements? Why they call it transition elements?
They show
Transition
different.
means change. Transition means change. In the periodic table, the left side elements, that is which block?
S block.
Black.
S block.
Are what type of nature they have? Are the metals or non-metals?
Electropositive.
They are
Electropositive. Metal, sir.
electropositive nature. Very good. That is, they have metallic nature. On moving from left to right, gradually the metallic character decreases and the non-metallic character increases. Okay. So therefore, you can say these are
Non-metal.
non-metal. Of
Non-metals.
course, some metals also there, some metalloids also there in the P block. Metals, metalloids, non-metals. All non-metals are present in which block?
F block.
P block. Of course, in this P block, besides non-metals, some metalloids and metals also there. Right. So, on moving from left to right, the nature of element changes from metal to non-metal. It does not take place immediately. It slowly metallic nature decreases and non-metallic character increases. The change from metallic to non-metallic takes place through these elements which are present between the S and P block. Therefore, these are called
Transition element.
elements. Okay. Why these are called transition? The transition from metallic to non-metallic nature of the element takes place through the middle elements. The middle elements are D block elements. Therefore, these are called transition elements. Is it okay?
Okay, sir.
Right. Now,
Okay, sir.
what is the general electronic configuration of transition elements?
N minus 1.
N minus 1. NS to N minus 1, D 1 to 10.
D1 to 10, NS
D1 to 3.
NS
0 to. Yes, sir.
Okay. So is it for D block elements or transition elements? Is this for transition elements or D block elements? This particular configuration is for
Transition
D
elements.
block elements. So what is the general electronic configuration for D block elements? N minus 1, D1
To 10.
0 to
2.
2. Right. So what are D block elements mean? Simply, already we discussed it. The differentiating electron enters into penultimate shell of the D orbital. Penultimate shell of the D orbital. Of course, there is a scope for the 10 electrons in the D orbital. There are 10 groups, and therefore you can write the configuration from 1 to 10.
Yes, sir.
The D shell. D subset. And what about transition elements? What are transition elements?
D
1 to 9. 1 to 9, sir.
1 to 9.
1 to 9. Very good. Because transition elements, of course, they are D block, no doubt. They are
Yes,
D block. But in which the
Not completely filled orbital.
is not completely filled.
Filled.
Not
Yes, sir.
completely filled. That is partially filled or incompletely filled. N minus 1 D subsets will be observed in the transition
Transition
elements.
elements.
Therefore, the configuration is 1 to 9
9.
and 0 to
0 to 2.
this is the general definition of the d block elements and transition elements. Right. Now we will discuss some properties of d block elements today. Now tell me, are they d block elements? Are they metals or non-metals? D block elements.
Non-metals.
Metalloids.
Metallites.
All d block elements are
Non-metals.
Metals.
Metallites.
metals. S block elements are purely
Soft metals. Soft metals.
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 yes, except
Soft
except hydrogen, all S block elements are metals.
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 While moving from S to P through D, the metallic character decreases.
Nature is decreases.
Yes, when we move
Non-metallic.
to character is increases. In the middle, we have these metals, these elements, which have the metallic characters. Is it okay?
Yes, sir.
Right. So therefore, the first point is the D block elements are trans elements they are metals in nature. Okay. Right. No metalloid is there in this. All are metals. All D block elements are metals. Right. Now, and what are the general properties of metals? What are the general properties of metals?
Electrical conductivity.
Very good. Yes, they are good conductors for
Heat and electricity.
Catalyst.
very good heat and electricity. So, like any metal, the D block metals also conductors of heat and electricity. Okay, because the metals generally they allow the flow of heat and allow the flow of electricity. Any other general characteristics of the metals? Compared to S block metals are soft in nature, whereas the D block metals are hard in nature. Are you getting my point?
Yes, sir. Due to strong metal-metal bonding.
Soft in nature, whereas D block metals are hard in nature. Why the D block metals are hard in nature?
Due to presence of metal-metal strong bonds, sir.
Very good. Due to presence of metal strong bond. So in D block elements, in several areas, we will see metallic bond.
Metallic bond.
Metallic bond and also covalent bond. Metallic bond and covalent. Due to this covalent bond, metal covalent bond, they are hard in nature. Why the covalent bond exists? Because
mutual sharing.
Yes, they have vacant d orbitals or incompletely filled d orbitals. Therefore, one metal with incompletely filled d orbital and another metal with incompletely filled d orbitals overlaps with each other and they form covalent bond. As the number of unpaired electron increases, overlapping is increases. Therefore, metallic bond increases. Therefore, hardness increases. Why metallic bond? What is the metallic bond? Metallic bond is due to the S block elements, sodium, potassium, rubidium. See, are the metals or non-metals?
These are metals.
Metals, sir.
Why they are metals? There exists metallic bond due to the S electron, due to presence of the S electrons. Here also, we have seen the electronic configuration N-1D, N-1D, 1 to 10, NS 0 to 2. Due to presence of S electrons of this metal and S electrons of this metals are responsible for the metallic bond. So therefore, the metallic bond is responsible by the S electrons, whereas the covalent bond is responsible by the unpaired d electrons in the orbital. Due to presence of these two bonds, metallic and covalent bond, these metals are relatively hard compared to the S black metals. You know, S black metals may be cutted with knife, but
Yes,
it is
sir.
very difficult to cut these metals with the knife. So why the difficulty? Because there is a strong or a hard bond exists in the D black elements. Is it okay?
Yes,
Okay.
sir.
Right.
Okay.
Next one more point. Melting and boiling points.
Yes, sir.
What about the melting and boiling?
Increases in the first series, sir. First.
Amma?
Increase with the number of unpaired electrons.
Very good. So the melting and boiling points increases with number of unpaired electrons. As the covalent bond increases, okay, the hardness increases. Therefore, melting and boiling point also increases. Comparatively, compared to the S black elements, the D black elements or trans elements have more melting points and boiling points because of the metallic and covalent bond. Okay? Is it okay?
Yes, sir.
I'm talking general properties of all metals. And what about density? What about density? The density of D black elements are much more than the S black elements. From left to right, what is decreasing? Atomic size decreases. Okay. Or atomic volume decreases. Okay. In the periodic table, as we move from left to right, with few exceptions, there is decrease in the what? Volume. Atomic volume. When volume increases, with increase in the atomic number, what increases? Mass number increases. When mass number increases, density increases. Therefore, in any transition series, while moving from left to right, the density increases. Is it okay?
Yes, sir.
Yes, sir.
In the periodic table, which elements have highest density?
Tungsten, sir. Tungsten. Iridium.
Iridium has the highest density, mass to volume ratio. It is 22.61 grams per centimeter cube. So next to this one, osmium. Osmium has 22.59 grams per centimeter cube. You see, just you take 1 cc of iridium, it weighs about 22.61 grams. That much denser this iridium. Therefore, the density of iridium is more in the D black elements. Which one is the least density in the D black? Which one is the less density in the D black?
Scandium.
Scandium, very good. Scandium, that is around how much its value? 3.43 grams per centimeter cube. So this is about the density and the highest density and the lowest density in the D black elements. Okay?
Sir, small doubt, sir.
Please ask. Please ask.
సార్ సార్ ఇప్పుడు ఎనిడియం కి ఎక్కువ ఉంటది కదా సార్ మేము మెల్టింగ్ పాయింట్ ఇప్పుడు క్రోమియం లాటిస్ ఎనర్జీ కూడా ఉంటది కదా సార్
చెప్పండి
ఇరిడియం కి క్రోమియం కన్నా ఎక్కువ ఉంటది కదా సార్ ఒక్కోసారి హై లాటిస్ ఎనర్జీ కూడా మెల్టింగ్ పాయింట్ లో ఉంటదా సార్
మెల్టింగ్ పాయింట్ అనేది దేని మీద డిపెండ్ అవుతుందంటే అమ్మా బాండింగ్ మీద మనం దాన్ని హీట్ చేసినప్పుడు ఆ లాటిస్ లో మనము ఎంత హీట్ సప్లై చేస్తే ఆటమ్స్ డిసోసియేట్ అయ్యి ఆ బాండ్ మెటాలిక్ బాండ్ డిసోసియేట్ అవుతుందో దాన్ని బట్టి అది మెటాలిక్ నుండి లిక్విడ్ స్టేట్ వస్తుంది సాలిడ్ స్టేట్ నుండి ఓకేనా
Okay, sir.
Right. So this is about the densities and some important points, the transition elements today is first of all, we discuss about electronic configuration. So previously, just now, we discussed about the general properties of the metals, that is metallic nature, hardness, density, all these general properties are discussed so far. Now, the electronic configuration of D block elements. So, what is the electronic configuration of D block element? Just now, we have seen the general electronic configuration is N-1, D1 to 10, NS0 to. Now, we'll discuss some important points, especially by keeping in view of 3D series elements. So, what are 3D series elements? You know, scandium,
Titanium,
Scandium, titanium,
vanadium,
iridium, chromium,
chromium,
manganese,
manganese, ferrous,
cobalt,
cobalt, nickel, copper, zinc.
copper.
What? Okay. So generally the common possible questions. So what is the configuration? You know, this is argon.
Argon.
3D1, 4S2.
3D,
3D1,
4S2, 3D, 3, 3D4, 4.
Here this is Excel. Okay.
Okay, sir.
Here again 3D5. Of course, this is 4S2.
4S2,
3D6.
3D6, 3D7.
3D8. 3D9. Here 3D10. Okay. Right. So according to this electronic configuration, as you see chromium and copper. What is the copper configuration?
3D,
3D10, 4S1.
4S1.
Yes, in 3D series, chromium and copper have exceptional.
Sir,
Amma.
4S1, sir.
Oh, sorry. Right. 4S.
4S1, 3D10.
Yes. 3D5, 4S1, 3D10, 4S. Okay. So why this is arises?
Half-filled stable.
Half-filled electronic configuration gives more stability.
More
Full-filled electronic
full
configuration
stable.
gives more stability. So
Yes, sir.
therefore, one of the electrons from 4s is promoted to the 3D. For the purpose of stability, there is a change in the electronic configuration of the chromium and copper. Okay?
Yes, sir.
Right. What about some other elements? Some other elements which have difference in the electronic configuration.
Chromium also, sir. Argon 3D5, 4S1.
Is this visible to you? I think it is so clear.
No, sir. Little bit.
Okay. Even then, this is in the case of 3D. The case of 3D, the two elements have different electronic configuration for the purpose of stability. What about 4D?
Algodinium and silver, sir.
Niobium, molybdenum.
Niobium.
Molybdenum.
Molybdenum.
Palladium.
Palladium.
Silver.
Silver.
Ruthenium. Ruthenium, rhodium.
Ruthenium.
Rhodium.
And rhodium.
Yttrium.
Right. These elements have different electronic
Abnormality has one configuration.
abnormal electronic. The 3D abnormal is only two elements. In the 4D, we have niobium, molybdenum, palladium,
silver, ruthenium, rhodium.
Silver. Okay. In the case of silver, it is what?
5s1, 4d10.
Yes. 4d10, 5s1. What about niobium?
5s1, 4d4, sir.
What about molybdenum?
5s2, 4d5.
4d5.
5s2.
Is it 2 or 1?
2, sir.
Check it. Because chromium, molybdenum, tungsten. Chromium, molybdenum, tungsten belongs to same group. Chromium, molybdenum, tungsten. Is it? So like chromium D5S1, molybdenum will have also D5S1. Like copper, silver also have D10S1. Is it okay? Is it clear? In the case of molybdenum and silver, due to the off-field and fill-field configuration gives extra stability. Therefore, molybdenum and silver are shows different electronic configuration than the expected. So this is explained in terms of off-field stability and full-field stability of the d orbitals. What about niobium, palladium, ruthenium and rhodium? These configurations are explained in terms of nucleus electron attractions and electron repulsions. The stability in terms of electronic configuration, these have different electronic configuration. This is what niobium has 4d4 5s1, whereas palladium 4d10 5s0. Is it okay? This is s0, but this is d4. What about ruthenium? D7. What about rhodium? D8. So the different electronic configuration of these four elements are explained in terms of nuclear electron attractions and electron responsible or responsible for the abnormal electronic configuration of these elements in the 4D. What about 5D series? What about 5D series? In 5D, which one?
Platinum, gold.
Very good. Platinum and iron, gold are with the abnormal electronic configuration. You know, iron is belongs to copper, silver, iron. Copper,
Yes,
silver, iron same. Therefore, silver is 4D10.
5D10,
6s1.
6S1.
So this can be explained in terms of
Fully filled stability.
Of course, here 4F14 also enters. 4F14, 5D10, 6F1. What about platinum? This is D9, yes, D9, D9, 5D9,
5D9, 6S1. 6S.
So, of course, 4F14.
Yes, sir.
So, this is about the difference in the electronic configuration in the 5D series. So, platinum and iron. Here also, there may be nucleus electron and electron repulsions are responsible in the case of the platinum. In the case of iron, it is the fulfilled d electrons are responsible. So, this is about the some important points in the electronic configuration where there is a scope for asking the questions. Especially they will ask from the 3D series generally, chromium and copper, and of course in the 4D, 5D also now and then they will ask the questions about the anomalous or different electronic configuration of elements. Now next important point today we will discuss about variable oxidations. Variable oxidations. Okay, so before this, let me ask a few questions. So D block elements are classified into how many series?
4 series.
Very good. What are those?
3D series,
3D,
4D,
4D, 5D, 6D.
6D. Okay. How many elements are there in the D block? How many
32.
elements are there in the D block? How many elements are there in the D block?
40.
100.
Only D block, in the D block.
40.
Very good. What?
40. Page 40.
there are 4 series. There are 4 series: 3D series, 4D series, 5D series, 6D series. In each series, so each series have 10 elements. Therefore, there are 40 elements.
40 elements.
Right. So 3D, the D series start in which period? The D elements.
Which
Fourth period.
six period.
Fourth
Fourth
period.
period. This is fifth period. This is sixth period. This is seventh. You know, hydrogen, lithium, sodium, potassium, here calcium, scandium. So therefore, the D series are this also called first transition series. Transition series. The first transition series elements start in which period?
Fourth period.
So these transition series are called 2D series elements. What about 4D? This is called second transition series, third transition series, fourth transition series. Okay. So sometimes this question also asked in the previous exams. I think it is CPZ or somewhere else. So the D block elements start in which period? Fourth period. So the elements in the fourth period, the D block elements in the fourth period are called first transition, second transition, or fourth. First transition are 3D. What are 3D elements? The elements from scandium 21 to zinc 30. So like this, you have to remember each series. How many groups are there in D block?
10 group.
Very good, 10.
Group.
From where it starts?
Scandium.
Third group, sir.
Very good. Very good. From according to UPSC, 1 and 2 are S block. From 3 to 12, the D block. So therefore, the D block are placed in how many groups? 10 groups. From 3 to 12 groups. These are placed in 4 periods. Of course, from 4th period to 7th period. Right? So next, variable oxidation states. This is very, very important question, important topic. So, to discuss about the variable oxidation, what is oxidation state? What is oxidation state?
The tendency of lose electrons, lose the valence electrons.
For example, FeCl2 and FeCl3. So, what is the oxidation state of iron here?
The +2, sir.
FeCl2.
This is +3. So, right. So, now what is variable oxidation state? Oxidation state is what? It is the charge appearing on one atom in a molecule. One atom in a molecule. Okay. In this molecule or in this compound, the charge appearing on iron is +2. Therefore, its oxidation state is said to be +2. Where about this iron is?
+3.
What about the oxidation state of chlorine here? What is the oxidation
One chlorine atom -1, sir. ఒకటే chlorine ఉంటే -3.
This chlorine.
2 ఉన్నాయి కాబట్టి.
So oxidation state means it is only for one atom. It is the charge appearing on single atom. Okay. So in single chlorine -1 and both the chlorine -2 means it should have +2. So this is what oxidation state. It may be minus or it may be plus or it may be something else. Right. So now the beautiful character of transition elements, not only this variable oxidation state, color property, magnetic property, catalytic property, formation of complex compounds, formation of allies. All these are said to be the specular characteristics of the transition element. Okay. So one of these specular characters, one of the special properties of the metals are variable oxidation state. Variable oxidation state is nothing but existence of one element in different oxidation states in the different compounds. Existence of one element in different oxidation states in the different compounds are said to be variable oxidation state. Here, I would like to ask you one question. What about the oxidation state of the S block elements?
+1. +1. +2 కూడా వస్తుంది సార్.
+1 +2.
మెగ్నీషియం కూడా వస్తుంది.
+1 +2.
Yes, if it is alkali metals, +1. If it is alkaline
metal +2.
+2.
This is the group 1, this is the group 2. So for group 1 elements, the common oxidation state in its compounds, not in the elemental state I am asking. I am asking in their compounds. Okay. Sodium chloride, potassium chloride, rubidium chloride, cesium chloride, whatever it, I am asking oxidation state in their compounds is +1. Similarly, it is +2. So what we understood? The general electronic configuration is NS1. The general electronic configuration is NS2. Therefore, for S block elements, the common oxidation state of elements in their compound is equal to the number of valence electrons. Okay. As they are metals, they possess positive oxidation state. If they are non-metals, generally they may possess negative oxidation state. Right. For second group or alkaline ethanol, it is +2. What about P block elements? For example, carbon, nitrogen, oxygen, here chlorine, of course. So carbon generally -4,
-4, -3, -2, -1.
Okay. Right. So as we move, of course, as we move from left to right, the positive oxidation state is never shown. Generally, they will show negative oxidation state. This is for the stability reasons only, for the purpose of stability reasons.
Octet configurations nearest.
Octet configuration, generally, positive, they will show negative oxidation. Valence is different. Valence is different. What is valency? Valence is the
outermost orbital.
Carbon valence is 4. Nitrogen valence is 3. Oxygen valence is 2. Chlorine is 1. So this is 8- group number. 8-, what is the group number? 4. Of course, 14. This is 5. This is 6. 8- group number. 8- group number. 8- group number is the valency, whereas the oxidation state is charge possessed on each atom is the oxidation state. Why I am telling? We are in D block elements. So S block elements, each group shows only. Sodium always shows +1 only. Beryllium always, magnesium always shows +2. So compared to these P block, what about P block? Lead. What is the oxidation state of lead here? Lead belongs to which group?
4th A.
4th A, 14. Right. Here the oxidation state of lead is +2.
+2.
Here lead is +4. So this is 4th group. The minimum oxidation state. What is the 4th group? General electronic configuration NS2, NP2. So the minimum oxidation state is equal to the NS electron. The maximum oxidation state equals to NS and NP electrons. But here, if you see the change in the oxidation state, the difference in the oxidation state, you will be observed here. How many units are there? Generally, 2 units. This is +2. This is +4. What is the difference? Difference in the oxidation state is
+2.
2 units. Okay. Even you take nitrogen or you take oxygen, you take chlorine, whatever it may be, generally the p block elements generally shows difference in the oxidation state by the +2 units. 2 units. Are they showing the variable oxidation state? Are they showing variable oxidation state or not?
No,
P
sir.
block elements also show variable oxidation state, but not maximum extent. S block elements don't show the variable oxidation state. Always they show either +1 or +2. But compared to these two, the elements which are present between these two shows more number of oxidation state in their compounds. Why they show variable oxidation state? What is the cause of variable oxidation state? Tell me.
There's energy difference between the D and S blocks, sir.
Yes. So always the oxidation state of an element depends on its what? Its electronic configuration. Oxidation state. For example, SCCl2, SCCl3. Explain the formation of SCCl2 and SCCl3. Scandium dichloride and scandium trichloride. Explain. What is the oxidation state?
+2, sir. +2, generally +3, sir.
How it is +2? How it is +3? Explain in terms of electronic configuration. Scandium 21, argon 4s2.
4s2, 3d1, sir.
If
Loss of
only S electron involves in the bonding, it shows +2 oxidation. In addition to this S electrons, if the D electrons, N-1 D, these are NS, this is N-1 D. How many electrons are there in D cell? 1. This S and this 4s2 and D1. If these 3 electrons, that means here NS electrons and N-1 D electrons are involving in the bonding, then it is showing the +3 oxidation state. So therefore, the variable oxidation state of any transition element, whether it is 3D, 4D, 5D, 6D, the variable oxidation state of transition element, because of the involvement of what? NS electrons and N-1 D electrons. Is it?
Yes, sir.
The minimum oxidation state of transition elements are due to involvement of
NSR.
NS electron, due to involvement of
NS electron.
the maximum oxidation state of transition elements equal to the number of S electrons and the number of D electrons involved in the N-1 D cell, from the N-1 D cell. Briefly, within no time, I would like to complete the variable oxidation state for the 3D series. The 3D series, to understand the oxidation state, that is variable oxidation state, one should be familiar with the electronic configuration. This is D1, D2, D3, D5, D5, D6, D7, D8, D10, right? D10. What about S? This is 3D, 4s2, 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 4s1. Only 4 I have written here. S2, 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 S1, S. Okay. So, according to their electronic configuration, show the possible oxidation state for scandium. Tell me this. If only S electron involved, +2. Okay. Titanium +2. Vanadium +2. This chromium +1. Okay. Because the minimum oxidation state equals to number of S electrons. Here copper is +1. What about remaining elements? When plus 2? Plus
Plus
2.
2.
Plus 2. Plus 2.
Plus 2. సార్ క్రోమియం కి +2 ఉండాలి కదా సార్?
ఉంటది, ఎందుకు ఉండదు? ఎందుకంటమ్మా క్రోమియం ఎస్ అవుట్ ఆఫ్ దీస్ 5 electrons 1 electron may involve, 1 d electron may involve, 2d involve, 3d, 4d, 5, any number of d electrons can involve depending on the situation. Okay.
Okay.
So therefore,
Sir, I have a doubt, sir. Sir. Sir, vanadium ki 2, 3, 4, 5 kuda vastadi kada sir oxidation state?
Yes amma. ఇప్పుడు నేను ఏం చెప్తున్నాను? First of all, I am telling the involvement of s electrons. When s electron involvement takes place, only 1 or 2 oxidation state, +1 or +2. Of course, here amma ఇక్కడ ఏమైందంటే వేరియబుల్ ఆక్సిడేషన్ స్టేట్ ఎందుకు ఎగ్జిబిట్ చేస్తుంది అంటే జనరల్ గా ఏం చెప్తున్నాము, వీటి ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ n-1d 1 to 10 ns 0 to 2 కాబట్టి ఈ మినిమం ఆక్సిడేషన్ స్టేట్ ఏదైతే ఉందో అది ns ఎలక్ట్రాన్స్ ఇన్వాల్వ్మెంట్ వల్ల పాసిబుల్ అవుతుంది. ఇక్కడ కాపర్ లో క్రోమియం లో మినిమం ఎంత ఉంది? s లో 1 కాబట్టి +1. కాపర్ కూడా మినిమం +1. why copper and chromium shows +1 oxidation state means you can explain in terms of S1 configuration. Okay. All other D elements, all other D black elements, whether it's 3D, 4D, 5, generally they will show the common oxidation state. What is the common oxidation state for any D black element?
+2.
So generally it arises from the involvement of S electron. Generally it arises from the involvement of s electrons. But of course, in the case of chromium, 1 s electron, 1 d electron also involved. The copper, 1 s electron, 1 d electrons also involved. But what my interest or our interest is the common oxidation state of d black elements are, the common is what? For any d black element, common oxidation state is +2. Right. What about this scandium? Tell me the possible other oxidation state.
+3.
+3. When it shows +3, scandium shows +3. When it shows +3, when the 2 electrons from s orbital and 1 from the d involves, it shows +3. What about titanium? It also shows +3. What about vanadium? Will it show +3 or not? Tell me. Amma, vanadium will show +3 or not?
Yes, sir.
Chromium, manganese, iron, cobalt, nickel, copper. Copper very difficult. You can say it does not. What about titanium? Titanium common oxidation state is what? +2. When it is +3?
+4 kuda sir.
Very good. Now we are. Now tell me, what are the possible oxidation states for titanium? What are the possible oxidation states for titanium? +2, +3, +4. Okay. What about this vanadium?
+5.
+4,
+4 and +5.
What about chromium? +4, +5,
+6.
What about manganese? +4, +5, +6, +5. What about iron? +4, +5, +6. Not more than that. What about cobalt? Just up to +4 only. Here, just up to +4 only. So because here, you see, as you move from left to right, from scandium to manganese, what happens? D1, D2, D3, D4, D5. Number of unpaired electrons are increased from scandium to manganese. As the number of unpaired electron increases, so they will show maximum number of oxidation state. Okay. After manganese, there is a pairing of electron takes place. Pairing of electron takes place. So due to pairing of electrons, the number of unpaired electrons are decreased. Therefore, from iron onwards, the oxidation states are also decreased. So therefore, it is looks like a pyramid. Therefore, what we can say, the pyramid which shows the variable oxidation state of the 3D series. Okay. Which element shows the maximum oxidation state in the 3D series?
Manganese.
Manganese. Oxidation state in 3D. What is the maximum oxidation state in 3D series?
Sorry?
What is the maximum oxidation state in 3D series?
Plus
Right.
7.
What is the maximum oxidation state in the periodic table in a D black element?
Plus 8. Plus 8. Osmium.
Plus 8. Plus 8. Very good. By whom?
Osmium and ruthenium. Ruthenium.
And ruthenium. So this is the maximum oxidation state of D black elements. Of course, from 4D and 5D, osmium and ruthenium in the tetroxides. Okay. So this is about the variable oxidation state of the elements, involvement of S and N-1 D electrons. And a few more points, just a few more points here. The common important questions. Now, I would like to ask a question. So, for example, manganese is showing the different oxidation state. I will write MnO, MnO2, Mn2, O7. So this is what, these are what? Manganese?
Oxides.
These are manganese compounds. What is the oxidation state?
Plus 2.
Plus 2.
4.
Plus 4 minus.
Is it?
Yes, sir. Plus 7.
Okay, we have some questions on variable oxidation state. If a metal forms different compounds with a different oxidation state, the one with lower oxidation state will have basic in nature.
Yes, sir. Basic.
The one with the higher oxidation state
Acidic.
acidic
Acidic nature.
So, say man, this is metal, man is no doubt. Generally, metal oxides are basic in nature, sodium oxide, magnesium oxide, calcium oxide. Any metal oxide, generally basic in nature, where we study in the S black, okay, or P black. But when you come to the D black elements, where we see the variable oxidation for metals, at the lower oxidation state, generally their compounds are with the basic nature.
Basic nature.
With the highest oxidation state, they show the acidic nature.
Okay.
What about this MnO2? This is in between the highest and the lowest.
Amphoteric.
Very good. This shows the amphoteric nature. That's all. This is about the nature of oxides. Sometimes, what is the nature of oxides? If it forms a compound with the lowest oxidation state or with the highest oxidation state in terms of acidic, basic, and that type of. And the other one is, so this compound will have ionic nature. This compound have covalent. So with the lower oxidation state, this compound generally will have the more ionic character. With the highest oxidation state, it shows the covalent character. Because their empty d orbitals are there. Okay, so therefore covalent character increases. What about this particular MnO2? Both ionic and covalent characters. So this is about variable oxidation state. If any queries so far, please ask me. And the remaining topic we'll see tomorrow.
Okay, sir.
Okay, sir. Thank you.
Sir, PDF share చేయండి sir.
అమ్మ నేను కొంచెం దాన్ని పేరుగా రాయాలి తల్లి రాసి మీకు షేర్ చేస్తాను ఓకేనా
Okay.
Okay, sir. Thank you.
Please go through it. We may conduct some test in this after completion of the topic. Okay? Is there any query? Shall we stop or shall we discuss? Shall we discuss, sir?
As per
Amma?
your convenience, sir.
Okay. If you have any queries in this area, we will discuss. Otherwise, we will discuss tomorrow.
We will discuss tomorrow.
Okay, Amma. I would like to stop at this point. Okay.
Okay, sir.
Thank you.
Okay, sir. Thank you. Thank you.
Okay.
Thank you, sir.
Thank you, one and all.
Thank you, sir. Good night.
You go through it, please.
Sir, sure.
Anything. నేనే కదా వస్తు